In this video, we'll be discussing how to draw Lewis dot symbols for atoms, ions, and ionic compounds. And this topic is very important, especially to learn about bonding, whether it's covalent or ionic bonding. And let's start with what is a Lewis symbol. A Lewis symbol consists of the symbol of an element surrounded by dots as implied by the name, and these dots simply represent the valence electrons. Okay, and as I said before, Lewis symbol will help us to understand the nature of bonding through either sharing, and by sharing here I'm implying covalent bonding, or transfer of valence electrons. And here I'm implying that this is ionic bonding. Okay, and why do electrons need to be shared or transferred? Simply to acquire a stable electron configuration, which is the noble gas configuration, right? Which is an 8 valence electrons, also known as an octet. All right, and we will learn how to draw first the Lewis symbol for atoms and ions. All right, and then in this video, I'm going to show you how to go from ions to ionic compounds. And then in a different video, I'm going to show you how to draw the Lewis symbols for molecules and polyatomic ions. And here just is an example of how a Lewis symbol looks like. So for example, we have here the Lewis symbol of an oxygen. All right, and we can see here that there are 6 dots representing the 6 valence electrons of oxygen. So this is the electron configuration of oxygen. We can see here that there are 6 valence electrons. All right, so let's see how we can draw the Lewis symbol. So I broke it down into 3 steps. We will write the chemical symbol. So at the beginning of the semester, you learned the name of elements and you learned their chemical symbols. And then we're going to determine the number of valence electrons, either from electron configuration or group numbers. So group numbers are going to be the easiest, and I'm going to show you. All right, but you are required to know both. And then we're going to fill in the valence electrons around the chemical symbol. And this is not a random process. It's actually very strategic process. So we'll start by filling in the electrons singly, and we are going to fill them up to 4 electrons maximum. And I will show you on the next slide. And then more specifically, we are going to write, as I said, the first 4 electrons unpaired, and then we're going to start pairing them. So let's see how we can do that. So I'm going to do these 2 elements, krypton and germanium. So let's start with krypton. Krypton is in group 18 right here. So if it's in group 18, that means it has 8 valence electrons. Okay, so if it's in group 1, has 1 valence, 2 has 2 valence electrons. If you have something in group 13, 3 valence electrons, 14 4 valence electrons, and so on. So we have here 8, group 18, therefore 8 valence electrons. Okay, so I'm going to start by writing out the symbol for krypton, and then let me draw out the electrons in a different color. So I'm going to start by saying 1, 2, 3, and then 4, and then I'm going to start pairing them up. So it becomes 1, 2, 3, and then 4. So of course, this is a noble gas, has the most stable electron configuration. So it has naturally an octet. Now let's do germanium. and the germanium is in group 4. So let's highlight germanium. Germanium is right here. So it has 4 valence electrons. So I'm going to simply write germanium, and then I'm going to draw out the 4 valence electrons. All right, now I want you to go ahead and try drawing out the Lewis symbol on your own, and let's see if our answers match. I highly recommend that you practice this on your own and then check the answers with me after you finish them. Now let's see, nitrogen. Nitrogen is right here in group 15, so has 5 valence electrons. All right, and we have here nitrogen, so it becomes 1, 2, 3, 4. Okay, so we filled it maximum to 4, and then the 5th one is going to go here. Okay, so this is nitrogen, and we're going to do gallium. Gallium is in group 13, so has 3 valence electrons, so 3 valence electrons, so becomes gallium, and then has 1, 2, and then 3. Last one is rubidium. Rubidium is in group 1 and has here Rb and has 1 valence electron. I hope this was clear to you. And let's move on to drawing out the Lewis symbols for ions. So again, the goal for ions, right, when they lose or gain electrons, is to acquire the stable electron configuration for a noble gas, which has the general electron configuration of Ns2 and P6, right? And which is the octet. So this is the octet, or the 8 valence electrons. Now let's go through the steps very carefully and how to draw the Lewis symbol of an ion. So we will start by drawing the Lewis symbol of an atom. Say, for example, we have something like sodium. All right, sodium is a metal. Okay, so, and sodium, let's go back. Sodium is in group 1, so it has only 1 electron. Okay, and because it is a metal, it has the ability to lose electrons easier than gaining them. So in this case, and we already know that metals have low ionization energy, so losing electrons is easy for them. So in this case, I'm going to take away the electron, okay? Or if I have something like a cation, an anion, like chloride, okay? So chlorine is in group 7, okay? It's in group 17, okay? So has 7 valence electrons. So 1, 2, 3, 1, 2, 3, 4, 5, 6, and then 7. Okay, and in this case, if I am going to draw out the anion, right, I'm going to add 1 electron because it is a nonmetal, so it's easier for it to gain electrons. Okay, so it becomes something like this. Okay. And then we are going to put the symbol in a bracket and then add the charge as a superscript. So for example, the sodium, in this case, since it's a cation, becomes Na plus with no valence electron because it lost it, or chloride, in this case, with a negative charge, and becomes like this, okay? Now we still are not drawing any ionic compounds. So let's see if we can draw out the Lewis symbol for the selenide ion. So selenide, where is selenium? Selenium is in group 16. Okay, so let's see selenium. Let me highlight it with a different color. It's right here. It's in group 16. So it has 6. The atom has 6 valence electrons. Okay, so we draw out 1, 2, 3, 4, 5, and then 6. All right, and since it gained 2 electrons, I'm going to pair it up, and then I'm going to put it in brackets and add a charge. Now, same thing for bromide. Bromine is in group 17. So bromine has 7 valence electrons. 1, 2, 3, 4, 5, 6, and then 7. And then since it gained 1 electron, I'm going to pair it to form the octet. And then I'm going to put it in a bracket with a negative charge. Now, again, I want you to start working on this on your own, pause the video, and then check your answer. So for potassium, potassium is in group 1. Okay, so it has 1 valence electron. Okay, we can draw it right here. And since it lost 1 electron as indicated by the positive charge, I will take it away. And then I'll put it in bracket and have a positive charge. Let's see where tin is. Tin is in group 14. Let's highlight it. So tin is right here. So it has 4 valence electrons. Okay, so the element has 4 valence electron, which is 1, 2, 3, 4. Okay, and since it, before drawing the bracket, since it lost 2 electrons, I'm gonna just take them away. All right, as indicated by the positive charge, and I will put it in right here. Now, hydride ion, hydrogen usually has 1 electron, okay? And since it gained another one, it becomes 2 electrons, all right? And then it has a negative charge, so it becomes like this. I hope this makes sense. And let's now move on, build off of the ions to discuss how we can draw Lewis structures for ionic compounds. Now, we now know how to draw the ions. So the Lewis structure for ionic compounds really represent the whole picture of the electron sharing, okay? And the only element that I'm going to add to it is just balancing the charges, because we know ionic compounds are neutral species, okay? So they are neutral species, okay? So we know how to write out, so let's go through the steps very quickly. We know how to write out the Lewis symbols now for cations and anions, and then we're going to simply neutralize the charges and balance them. And I'm going to show you how the Lewis structure really represents this. So, for example, calcium, it is a metal. It is in group 2, so it has 2 valence electrons, right? But here we have, because it's an ion now, it's calcium ion, so it becomes, so if we draw the calcium, okay, with 2 electrons, because now it's a cation specifically, I'm going to delete the electrons and draw out a 2 plus charge. Okay, now for the chloride, chloride is the anion. Okay, actually, before I draw out, I actually am backtracking, so I'm going to show you calcium. All right, and then we're staying with the element so far, and then I'm going to draw the normal chlorine. So chlorine, and chlorine. So we have here calcium chloride is CaCl2. So chlorides, or the chlorines, and chlorine is in group 17, so has 7 electrons. And what happens is the calcium ion will give away 1 electron to each chlorine atom, so becomes Ca, then 2 plus, and then 2 chloride minus. Okay, and it becomes 2, 4, 6, 8. You can also draw it as, let me copy and paste this. Okay, and instead of putting a 2 in front of it, we can just delete this and just copy and paste this to represent that there are 2 chlorides. Okay, I hope this makes sense and I hope it's easy for you. Now let's work on some more practice problems. And we have here starting with aluminum sulfide. So we have aluminum is Al3 plus, and then sulfide is 2 minus. If we do the crisscross method, it becomes Al2S3. So in this case, if I have 2 aluminum, so let's go back. Aluminum is in group 13. Let's double check. Yes, it is in group 13. Let's highlight it with a different color. Here, aluminum. So it has 3 valence electrons. Okay, so aluminum, the element. We're not still ionizing it. Okay, and then aluminum, because we have 2 moles of it. So aluminum. Okay, and then we have 3 sulfurs. So sulfur is in the same group as oxygen, so it's in group 16, so it has 6 valence electrons. So we have here sulfur, 1, 2, 3, 4, 5, then 6, and then we can copy and paste this. Okay, and then 1 more. All right, and what happens is each aluminum right here will fill in the octet of the 3 sulfurs, right? So for example, let me draw this with a different color. So it will fill in 1 here and 1 here, and the other electron will go in here, okay, and it will take 1 more from here. Okay, and then the rest of these 2 are going to go to the sulfur, so becomes 2 Al3 plus and 3 S 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we have here 2 minus, or alternatively, you can draw them as a, didn't copy the positive sign, and then we're going to copy the sulfides. Hopefully it transfers. Copy, paste, paste, and then paste. Okay. All right. Now let's go over to barium fluoride, which is BaF2. Now barium is in group 2. It's a metal, so barium has 2 electrons, and then fluorine is in group 7, all right, and has 7 valence electrons. 1, 2, 3, 4, 5, 6, and then 7. Okay, and the barium will donate 1 electron to each of the fluorine atoms, so becomes Ba2 plus and 2F minus. Okay, or we can draw it as Okay, and remove the coefficient of 2 and just simply copy this and becomes, let's remove the 2 right here, and it becomes fluoride.